We've all been there. You know, you're set up for a huge presentation, maybe a movie night, and the screen just flickers or goes black.
And it's almost always a cheap cable giving up.
Right. But imagine that failure happening during, say, a surgical procedure or at a stadium where the source is 300 feet away from the display.
That is the absolute nightmare scenario for AV professionals, and that really is why we're looking at the Kramer CLS AOCH 6295 today.
A cable with an MSRP of, what, $1,140?
Yeah, and even with a street price that's closer to 900, it's a serious piece of hardware.
It is. But I guess to understand that price, you have to get what problem it's solving.
Exactly. This isn't for connecting your PlayStation to the TV. This is about critical infrastructure.
So our mission today is to figure out if a cable can actually be worth four figures, and I'm guessing we're fighting physics here.
We are. You know, a standard copper HDMI cable it has a hard limit.
Yeah.
Once you start pushing high bandwidth signals, like 4K past maybe 15, 20 feet.
The signal just dies. You get severe attenuation.
Precisely. You get those sparkles, but the whole thing just fails.
So how does this one do it over 90 meters?
Well, Kramer built it as an active optical cable. It's a hybrid. It actually draws a little power from the HDMI port itself.
To do what?
To power a tiny transceiver in the connector head that converts the electrical signal to light.
Ah, so it's basically a fiber optic run that it tricks the TV and the source into thinking they're connected by a regular copper cable.
You got it. And because it's using light, it can push the full 18 gigabits per second, that's your 4K, at 60 hertz, with full 4.4.4 chroma sampling.
With zero signal loss over the whole distance.
Zero.
And what about the audio?
Same deal. It handles things like Dolby Digital, True HD, DTS HD, Master Audio, no problem.
Okay, the bandwidth side makes sense. But here's where I get a little skeptical. The practical side.
Yeah.
If I'm an installer, I have to pull this 90-meter cable through a pipe in a wall. HDMI heads are bulky and kind of fragile. If you snag one,
You've just destroyed a $1,000 cable.
yeah.
It's a classic problem. Kramer's solution is what they call a pluggable design. The big HDMI connectors you see, they're actually removable.
Okay, so what's underneath? A micro HDMI, because those are famously easy to snap off.
They are, but they thought of that. It comes with this special pull-through capsule. It's a little metal sheath that locks over the microconnector.
So it takes all the stress of the pull.
Right. And get this, the cable itself is only 3.4 millimeters thick.
Wow, that's tiny. About 1/8 of an inch.
And it's super flexible. It has a bending radius of just 6 millimeters. You can pull it around tight corners that would just kill a normal copper cable.
Okay, speaking of walls, what about interference? A place like a hospital or a factory has high voltage lines everywhere. That's a ton of electrical noise.
And if this were copper, yes, you'd be in big trouble. Copper is basically an antenna for EMI and RFI.
But because it's fiber,
It's immune. The light signal inside is completely unaffected by electromagnetic interference. Your picture stays perfectly clean.
that handles the signal. But what about building codes? You can't just run any old plastic through a plenum ceiling.
Correct. And that safety rating is a huge part of the cost. The cable is rated as low smoke and halogen free.
Meaning if there's a fire, it won't release a cloud of toxic gas.
Exactly. It's often mandatory to pass inspection in commercial buildings.
Yeah.
It also supports all the protocols you'd expect, HDCP 2.2, HDR, the works. The connectors are even 24K gold-plated to stop corrosion.
So let's break this down then. For my home theater, this is just complete overkill.
Unless you happen to live in a palace, yes.
But for a university lecture hall, a surgical theater, a
Wow.
mission control room, you're not just paying for a cable, you're paying for a guarantee.
A guarantee that the image shows up perfectly, 300 feet away, every single time. It's that invisible infrastructure that makes modern AV work.
It does make you wonder, though.
What's that?
I mean, if we need all this tech-active optical conversion, hybrid fiber, just to move 4K reliably across a big room today, what happens when 8K or, uncompressed VR becomes the standard?
That is the big question, isn't it? If this is the kind of pipe we need for today's video, the optical highways we'll need for tomorrow, they're going to have to be massive. We might be nearing the limit of what we can hide inside a simple little connector.